Hi everyone, and thank you for being here. I'm Fauzi. Today I will present the holistic and ethical AI-powered academic advising system. So the core idea is to combine the strengths of large language models with explainability, fairness, and human oversight to deliver trustworthy, scalable advising system. So I will briefly motivate the problem, highlight the gaps in current solutions, introduce the architecture, and then walk through how we implement it responsibly, covering data integration, retrieval augmented generation, explainability plumbing, privacy, and bias controls, and evaluation. I will finish with expected benefits, limitations, and next steps. I will, I'm I'm excited actually to share how uh, this academic advising system turns buzzwords like ethical AI and explainable AI into actual testable software components. So for the agenda, here's the roadmap. I will start with motivation and problem space, then a quick literature snapshot and the ethical context, especially FERPA and the EU AI Act. The center of talk is the our actually academic advising system, which is the holistic and ethical AI powered academic advising system. The architecture, its modules, and how they work together. After that, I will dive into implementation details, data and knowledge integration, the RAG pipeline, explainability patterns, bias and privacy safeguards, and the hybrid advisor workflow. We, we will actually cover the evaluation plan and KPIs, compare, the HEAAS with the existing systems, and summarize anticipated benefits. I will also close with limitations and future work, and then take some questions. But in this slide, we won't take any questions. So the goal is for you to leave with both the why and the how. So the context why advising matters. Academic advising is central to retention, time to degree, and student well-being. Yet, most offices face high student to advisor ratios, policy complexity, and surging expectations um, for personalization. Students need timely, accurate answers even outside office hours, and support that reflects not only degree rules but also their interests, workload, tolerance, and career intent. Meanwhile, advisors are strengthened by repetitive administrative tasks, leaving less time for development conversations that actually change outcomes. This context motivates a system that can scale routine guidance while keeping humans focused on mentorship. That's a niche. He has aims to fill policy faithful, personalized guidance with transparent reasoning and clear rule for humans. The problem or the gap in current AI advising. So, existing AI advising tools have made progress, but several gaps remain. First, personalization. Many systems do not fully integrate institutional rules and student histories, so recommendations can be generic. Second, trust and opacity. So if students can't see why a suggestion was made, they may ignore it or worse, follow it blindly. Third, ethical um, risks. privacy, and algorithmic bias are real in education, which is sensitive domain. And finally, human oversight is often unclear. We need mechanisms for advisors to review, annotate, and override, and for the system to learn from those corrections. So the HEAAS, which is the Holistic and Ethical AI-powered academic advising system, is basically addresses these gaps with grounding, explainability, fairness, instrumentation, and explicit human in the loop design. So objectives and scope of the project or this research. Our objectives are fourfold. One, deliver holistic personalization by combining transcripts, remaining requirements, interests, and constraints like workload to ensure explainability. Each recommendation should come with evidence and a rationale students can understand, plus deeper traces for advices. Three, embed privacy and fairness by design, data minimization, access control, and bias monitoring with mitigation. Four, define an explicit hybrid model where advisors approve, annotate, or override, and those signals feed back into improvement. The scope here is a conceptual architecture and implementation blueprint. We are not presenting randomized trial results. We are showing a system design that's buildable and testable in a real deployment. So literature and existing work, basically. So the literature shows a clear shift from rule-only systems to LLM assisted advising with institution-specific knowledge bases. Systems increasingly decouple with the front and from the policy backend. So catalogs and rules can be updated without breaking the user experience. We also see retrieval-grounded approaches to reduce hallucinations, retrieving relevant catalog, text, and degree rules to feed the model. These trends are promising, but the literature also advises caution. We need formal evaluation frameworks, traceable reasoning, and disciplined deployment patterns. Our architecture builds on these advances and tries to make ethics and explainability first-class citizens, not afterthoughts. The key challenges is that for the challenges restrict accuracy and evaluation. LLMs can be persuasive, but wrong. So we need grounding and validation. Bias, both data and model artifacts can skew advice. Without monitoring, some students get worse options. Privacy, education data is sensitive. Compliance, access control, and minimization are non-negotiable. Explainability for non-experts, while shape and line are helpful, and these are basically models that are described in the research paper. They are helpful. Raw plots aren't ideal for students. We need legible rationals that link to policy anchors and show requirements deltas. Our proposed architecture directly tackles these: symbolic validation, fairness, dashboards, and architecture, designed the architecture that we proposed aligned design and explanation patterns tailored to different audiences, students, advisors, and auditors. So ethics and regulation in education. So in education, the bar is high. In the US, FERPA governs access to student records and demands strong controls. In the US, in the uh, European Union, the AI Act often classifies educational advice systems as high risk, triggering obligations around risk management, transparency, human oversight, and post-market monitoring. And beyond law, campuses are moving toward FAT principles: fairness, accountability, and transparency. Our proposed architecture bakes these in: encryption and rule-based access, mutation audit logs, advisor oversight, and regular AI audits. The design assumes we will publish clear documentation of system capabilities and limits, and that governance bodies will review fairness and performance each term. So the overview of our architecture is a multi-layer architecture. Data uh, and the key B layer that houses students' state, catalogs, and prerequisites graphs. An AI layer combining retrieval augmented generation with explainability, an application layer that enforces business logic, validation, and policy checks, and a UI layer for students and advisors. Core modules include student profile and knowledge-based integration, explainability model, ethical bias mitigation, and hybrid advising with advisor in the loop, and feedback for continuous improvement. The philosophy is that ground every suggestion in policy and student context, explain it in clearly, and keep a human in control for the edge cases. The architecture design. So this diagram shows data flowing left to right. On the left, we ingest the student profile and the institutional knowledge base catalog, program rules, and prerequisites graph. The retriever fetches relevant passages and rule snippets. The large language model, the LLM, synthesizes candidate suggestions, but we don't stop there. A symbolic validator checks prerequisites, credit caps, and rule expressions. Finally, the explanation packager bundles bundles the recommendation with policy citations, requirement deltas, and confidence. On the button pad, the advisor UI supports approve, annotate, override those signals, feedback into retrievals, prompts, and rankers for iterative improvement. So, student profile and knowledge base. This module unifies what advisors already use: transcripts, remaining requirements, uh, plans, holds, accommodations, interests, and goals, you know. And for policy, we maintain the catalog and program rules, plus a prerequisite graph. A key design choice is to encode degree logic in auditable expressions and think named requirement buckets and DNF CNF rules. This let us run the symbolic checks and how students exactly and show students exactly how a suggestion helps them progress. For example, this course satisfies area C. You will have 3 credits left there. It also allows unit testing for rules so catalog changes don't break the degree logic. So the two modules, we have explainable AI and ethical or bias subsystem. So explainability works at 2 levels. For students, we show evidence cards. The policy expert um, expert, the requirement delta, and one or two salient signals like workload fit. For advisors, we add local attribution on rankers, for example, shape or line for the top K candidates, and show retrieval sources and rule checks. The ethical subsystem enforces data minimization and encryption, rule-based access, and audit logging. It also powers fairness dashboards, so we track whether different groups see equally feasible options and whether rates vary. We schedule bias audits each term with mitigation loops such as reweighting and counterfactual data. The other two modules are hybrid and continuous improvements. So the hybrid design makes a human role explicit. Advisors see a queue of AI student interactions with risk flags and confidence. They can approve, annotate, or override any suggestions. Overrides aren't dead, dead ends, basically. So they became learning signals, updating prompts, rankers, or retrieval weights. Students get a why. So here expander on each suggestion and a one-click request advisor review, for example. Okay, so this flow does two things. It keeps students supported around the clock, and it reallocate advisor time from repetitive admin toward developmental advising while improving the system term after term. Implementation. So we have data and RAG pipeline. The data, so here's the advising pipeline. Step one, we pass the student's question. So we pass the student question, classify intent, and detect constraints, term, workload, cap, campus, modality. And step two, a hybrid retriever searches both instructed policies and structured rule snippets. Step three, the LLM emphasizes candidate plans grounded in those materials and in a compact summary of the student's degree state. Step four, a symbolic validator ensures uh, prerequisites and credit caps are met, attaching human readable violation messages if not. And step five, we package the response with citations and requirement deltas. This workflow reduces hallucinations and make various suggestions traceable. So the implementation of the both architectures is that we pre-compute or cache explanations for common scenarios to keep latency low. For fairness, we define group matrices on exposure to feasible courses, plan acceptance, and time to plan. We monitor drift if a new catalog shifts prerequisites. We detect and test it. On privacy, we practice data minimization, encrypt P2 at rest and in transit, and on enforce need to know access. We avoid training on raw PI, P2, sorry, where feasible. Where feasible, we apply differential privacy for fine-tuning. For ambiguous or low confidence cases, we automatically raise an advisor review flag instead of pushing a brittle answer. For the API and UX highlights, so the public API is intentionally narrow to reduce risk. The workhorse is the basically the version one advice slash plan, like ranked courses and rationals, which returns ranked courses plus rationals and policy anchors. So basically, it returns these two uh, data. And the other one is degree and audit, remaining requirements and rule IDs. And the other one, which is policy, research, powers RAG, and the other one, which is the late one, is the moderation and review, records advisor, decisions for learning. In the student UI, the chat plus plan builder surfaces suggestions with a Y expander. In the advisor UI, we show a timeline of interactions, risk flags, and the one-click approve, annotate, override, plus analytics to spot patterns and reach out to students who may need human help. For evaluation, we evaluate across 5 dimensions. 1, plan feasibility rate. Do suggested plans actually meet prerequisites and rules? 2, time to plan and latency SLAs. Is it fast enough to be useful? 3, faithfulness at K. How much of the rationale can be traced back to retrieved passages? 4, advisor override rate and latency. Are humans comfortable and efficient? 5, fairness matrices across protected classes, exposure, feasibility, and acceptance parity. Where feasible, we run term-long A/B tests to track retention, course success, and advisor satisfaction. This makes improvements measurable, not aspirational. Comparison. Compared to existing LLM advising solutions, our proposed architecture makes ethics and explainability core modules, not add-on. It blends RAG with symbolic validation, so suggestions are both fluent and policy fitful. It treats personalization holistically, not just you need 3 credits, but this fits your interests and workload. So it basically explains better to the student. And it defines a real advisor in the loop, overrides feed the learning loop, creating institutional memory. In short, it's not just a chatbot on top of a catalog. It's an auditable advising system with governance, hooks, and KPIs tied to student success and equity. Anticipated results and benefits of this system is we expect several benefits. Students get clear, timely guidelines with transparent reasons, leading to higher plan adherence and less confusion. Advisors also can recover time from routine scheduling and can invest it in development advising. Institutions gain consistency. The same policy is applied to the same way. So with citations, explainability with audits, build trust with students, advisors, and administrators. And because of the system logs feedback and measures fairness, it can improve each term. The overarching aim is better retention, time to degree, and equity of access to opportunities like minors, certificates, and honor tracks. The limitation of our system and the future work that can be done, to improve it is that for the limitations, this is conceptual and engineering blueprint. We still need full implementation and empirical validation in production settings. Explainability can add latency. We will mitigate which caching and selective depth. The knowledge base needs active curation. Catalog drift is real. Fairness matrices require careful interpretation and stakeholder governance. Future work includes campus pilots, Rigorous A/B testing, expanded well-being and engaging signals, and hardening fairness mitigation. We will also explore causal evaluation. Do explanations themselves improve adherence and outcomes for the students to benefit from? And we plan to publish regular transparency reports after audits. So we conclude our, more like architecture improvements and our finding and the novelty of this research done is basically our architecture is ethical, explainable, and hybrid advising architecture. So it grants LLMs in institutional policy and student context, validates suggestions symbolically, and explains decisions in a language that people can use. It embeds privacy and fairness controls, and it keeps advisors firmly in the loop, which is very important. Most importantly, it turns reasonable AI principles into concrete endpoints, workflows, and KPIs that can be built and measured. And thank you very much for following with these slides. And here's some of the references selected for this research paper. Thank you very much.